Symmetry and transformations in this mini lesson. We're going to talk about symmetry, and then we're going to talk about the transformations of rotation, reflection, translation, and dilation. We're going to see examples of each of those and get a brief overview of what they do. So first off, symmetry. Symmetry is when an object can be folded in half and both of the sides are the same. So the line that we cross or fold it over is called the line of symmetry. Let's look at a couple of shapes and actually find lines of symmetry. Here are three figures. The first one is our trapezoid over there on the left. And is there a place where we can draw a line that we could fold over that line and both the left side and the right side would be exactly the same? Yeah. You notice that this one here, the vertical line, if you were to fold across that line, both sides of this figure would be the same. You couldn't draw a horizontal line because they're different from the bottom to the top, but we could draw one this way. Look at our second figure. That one has a horizontal line of symmetry. It also has a vertical line of symmetry. Notice you could fold the figure in both of those ways, and you would get a nice, consistent, similar side. And our last figure, this hexagon, has a vertical line of symmetry, a horizontal line of symmetry, but it also has some other lines that we could draw where we would fold them and they'd be the same on either side. There's this line. Notice if you were to fold across that line, you get something the same on all sides. That line and that. Oh, let's do those ones first. The lines that go through to the vertices of this figure would all give you lines of symmetry. We could also fill in all of these lines. So this one here has lots of lines of symmetry. This is a regular hexagon, has lots of lines of symmetry. So basically what you're looking for is lines where you could fold the shape and you would get the same exact thing on both sides of the line. Now we're going to talk about our transformation of rotation. Rotation is what we call an isometric transformation. That means it moves the object, but it does not change the size. In other words, the starting figure is congruent to the ending figure. Congruent meaning that all the side lengths and angle measurements are all the same when you start and when you finish. So this is what rotation looks like. You start off with a point. That's called our point of rotation. And then you have a figure, some kind of figure. In this case, I'm going to use a green arrow. And you rotate that figure around the point. All right? So notice that the arrow remains the same size. This is an isometric transformation. The arrow remains the same size. It just rotates around that point. Now the point can be on the edge of a figure, it can be inside the figure or outside the figure, but basically if an item is rotating, this is the rotation transformation. The next transformation is reflection. Reflection is also an isometric transformation. In other words, it's the same starting out as it is finishing. The figures are congruent. So let's look at an example of reflection. Here's a line. We call this the line of reflection. All right? And that line can be outside of a figure, it can go through a figure, or it can be kind of on the edge of a figure. I'm going to draw this shape. It's like a little Pac-Man-ish looking shape. And this shape, I'm going to reflect across my line of reflection. So it'll look like this. Bing. Notice how it reflected. Everything on the left reflected to the right, everything on the right reflected to the left. I'll show you that again. So this is a figure reflecting. Also, you notice that the figure remains the same size, so it is both the original figure and the new figure are both what we call congruent. They're the same. All right. The next transformation is called translation. This is the third type of isometric transformation we're going to talk about. In other words, the figures at the beginning and end are congruent. This is what translation looks like. Basically, it's moving an object. So I can take this octagon, looks like a stop sign, and I move it. That is a translation. I'm translating it from one place to another. All right? That's what I'm doing. When I move it back and forth, it's moving. That's a translation. Notice it's an isometric transformation, so the object remains congruent throughout. Okay? That is translation. The fourth and final transformation we're going to talk about is dilation. Dilation is not an isometric transformation. Dilation changes the size of the figure. So after we dilate a figure, it is no longer congruent, but it is similar. All right, and that's a key point. That's why this translation is different than the other ones we're working on. If you shrink something or expand it, which is what dilation is, then you are going to change properties of that figure, and the figures will remain similar but not congruent. Let me show you an example. I have this star here. And dilation is going to make it larger, like that, or smaller, like that. Larger and smaller. It's going to be changing the figure, like that. So again, these figures are similar. That means that the angle measurements are still the same, but the side lengths are different. So when you do a dilation, you are shrinking or expanding a figure, and you're going to change the properties of that figure. You're going to change them to being larger or smaller. And so the figures are similar to each other but not congruent. Quick recap. We talked about symmetry, how there's a line of symmetry. We talked about the three isometric transformations and dilation, which is a non-isometric transformation of changing the size of a figure. I hope that lesson was helpful for you. Have a wonderful day.